Thank you, and thank you for the invitation. By the way, CalNext is not over. It is continuing, but the flights that we were involved in are over. So we did fly as far north as Fresno during that experiment. So I'm going to talk today about pollen, and I'll talk about it very much from a physical point of view. I will refer to Richard for any questions regarding the disease of asthma itself, other than some physical perspectives on it. Pollen is a very interesting topic for study that I sort of stumbled into given my long background in looking at particles in the air, what we call aerosols, which include particles of all sizes. The picture that you're looking at is one of the most intriguing bits of pollen that we have seen. This is a high-speed film, 10,000 frames per second. It's actually very slow for this plant that is ejecting its pollen. The highest speeds that we have measured from this plant have been pollen being shot out by this neat little 3 millimeter long catapult at velocities of 237 meters per second. That is Mach 0.7. It is the fastest motion of any living thing on this planet yet recorded, and it is from a tree, one that occurs quite predominantly, I know, in the Davis area, the mulberry tree. And it is the fastest thing on this planet. We're not the first to observe this. Now here I give a quote from the real founder of allergy research, the person who wrote the first paper that I'm aware of on the problem of hay fever, which was John Bostock. Paper that was his paper on hay fever was published in 1809. But here he's quoting some earlier work about the mulberry tree. And I'll just read the last little bit of this. The germination, when it has once begun, bursts forth all over the tree at the very same moment. So much so, indeed, that is accomplished in a single night, and even with a noise that may be audibly heard. Now, you could find earlier writings about this in the Old Testament, where it was related as the March of the Philistines, the sound of the March of the Philistines. It is a noise that is not, as Bostock suggested, a mere fable. I've listened to the sound. It's a little bit too subtle to project, but you can actually hear it. So those of you who live around mulberry trees, when they're in bloom, you might watch the little brown weasel shot out of the flowers and hear the audible pop if you listen very carefully on a quiet morning. Yesterday we saw some really intriguing results from the San Joaquin Valley. Results that showed that during the month of May, during the year 2006, there was a pronounced excursion in the number of asthma-related emergency room visits. This I find very intriguing. This is what stimulated some discussions that David and Tim and I had regarding asthma and how it might be related to the pollen. It's part of the kinds of puzzles that have gotten me involved in this, and it's something that I see as an opportunity for future research. Now, pollen, people have been sampling pollen for a long time. They collect it with pollen and spore traps, and here you have a picture of what is referred to as the Burkhart Sampler. It's the classical pollen sampler. It's a Hirsch-type sampler, developed back in the 1950s, not improved significantly since. This device actually collects samples on a clear plastic tape installed on a drum that's turned with a wind-up clock. There are newer versions of this that use electric motors to turn the sample, but they have not otherwise changed significantly, nor, to my knowledge, have they ever been designed from an aerodynamic point of view to really optimize the collection. So when people report pollen counts, they're reporting numbers as collected with a standard sampler, not numbers that truly represent what's in the air. And to date, I don't know how we could measure what's truly in the air, though I keep thinking about that problem. It's an intriguing one. So what we're looking at, as we just heard, is not the pretty flowers. We're not looking at the pollen from the flowers that you like to look at. This is Bermuda grass. The flowers that you see here, if I can find my cursor, These little tiny anthers that you see hanging down here on the male Bermuda grass flower are tiny, 2 or 3 millimeters long. Each one will contain 50 to 70,000 pollen grains. They will open in the morning when the sun comes up, and if the wind is blowing or they're disturbed in some way, may disperse pollen into the air. This is more typical of how pollens are released. The mulberry tree is an exception. It's not unique in any way, but it is more violent than most. This is a time-lapse picture taken over a period of about 20 minutes, showing the opening of the anther on a ryegrass flower. This, by the way, is a picture that was taken by a high school student working in my laboratory one summer a number of years ago. And it shows very clearly the gradual opening, the dehiscence of the flower that exposes the pollen for dispersal. If you read the botany literature, you will learn that when the flowers dehiss, they disperse the pollen as though there's some magic force. But there are adhesion forces that are extremely powerful, so-called van der Waals forces, that bind the pollen very strongly to the surface and hold it unless it's disturbed. It requires a wind. But these flowers are evolved to allow the dispersal on a relatively gentle wind. So a wind of 2 or 3 meters per second is all it takes to blow the pollen off the flowers. If you were to try to put them on say a microscope slide and blow them off that, it would take a velocity that would be probably an order of magnitude higher. So we're interested in these little particles. Those little beads you see, by the way, are tiny. But they're huge. They're boulders compared to all the other particles anyone's talked about here. They're 25 microns for the smaller ones. There are a few that go down to about 15. The vast majority are 20 to 50. Some go up to more than 100 microns in diameter. The pine pollen you will see, most of the others are too small to see, but they still are sufficient. When they accumulate on the ground, you can see the dust, but you won't see the individual particles. The pollen particles take many different forms. And here's part of the problem on getting data on pollen, is what people do to determine how much pollen of a given species is in the air is they take a look at these tapes that have been collected with a microscope. Someone staring through the microscope, they see each of these different little particles. They identify it based on experience and count it. And so they will count all of the particles collected on this strip, or particles collected in a representative sample of the strip, typically with very poor statistics. If they report that they saw 10 particles per cubic meter, they're looking at a sample that represents approximately a cubic meter of sampled air, so they actually counted 10 particles. So the uncertainties in those numbers are huge. We don't, however, really have any good data on those statistics, though I have learned in talking to Kathy Hammond that she has the data from what her group has done, and we will be looking at that in the future as we try to improve our understanding of how the counting actually occurs. So these take many different forms, but let's just take a look at one of the really bad culprits. This is rye grass. And what you see here is a pollen. I don't know how it's appearing. I guess it's appearing pretty spherical on that projection. It's a spherical particle about 25 microns in diameter. It has a single aperture or pore in it. The surface of the pollen itself is textured with a nanostructured, very hydrophobic surface that will become important as we go on later. This one little pore, when the pollen lands on the female flower, it will grow a tubule from it that will extend out many, many diameters of the pollen grain from the pollen itself. And that carries the genetic material from the male pollen cell to the female flower. If we look at what happens to people when they experience this, these pollen particles are huge. The ryegrass is 25 microns in diameter. When you inhale it, it will deposit, because it's so large, in the so-called extrathoracic regions, the head and neck airways. It will not penetrate significantly to the lower airways. So unless there is some systemic physiological response, and here I will defer to the physicians in the crowd, I don't see how These particles can themselves trigger a local deep